Configuring printers and services for file sharing. Printing in Linux is very network oriented. The processes behind the scenes that are running the show, they can accept print jobs from remote systems as easily as local ones. And we'll learn how to install and configure a printer for your Linux machine. And then we'll move on and talk about file sharing. First we'll use a program called Samba. And that's so that we can share files between Linux and Windows machines. And we'll also touch on NFS, the networked file system, and that's the most common way that we use to share files between Linux machines. So let's get started. So let me give you a little overview here of the Linux printing architecture. Okay? I want to explain what happens between the time when you're sitting at your computer and you tell the computer to print something, and the time that that page comes out of the printer over here. I want to explain the steps in between. So the first thing that you have to do is initiate a print job. And one of the ways that you can initiate a print job is with the Linux command LPR. LPR just stands for line printer. You probably don't have a line printer. You might never have even seen an actual line printer. You probably have like an inkjet printer or laserjet printer or something. And LPR will still print to those. It's just the command, the name has stayed the same over the years. So they keep the command name LPR. Now what LPR does is it takes the thing that you want to print, the file, okay, and it gives it to this sort of overseer of the whole thing, which is LPD. The process name is LPD, and that stands for the line printer daemon. And remember, daemons are just these processes that are running behind the scenes taking care of things, and the LPD daemon is taking care of printing jobs. Okay? And what LPD does is it decides which print queue the job should go in. Okay? Now all the print queue is it's just like a line. Okay, like at the bank or something. You get into a line at the bank and you get at the back, and the people are serviced at the front one by one. Okay, so the print queues are over here. Okay, and LPD will decide which job your print queue should go into based on the specifications that you gave it. Okay, so a job would go in the print queue, and maybe there's a whole bunch of jobs in the different print queues, and these print queues can be serviced by maybe different printers. Maybe one print queue is for this printer to print one-sided, and this print queue is for this printer to print two-sided pages. Okay, so if this printer is capable of printing double duplex pages, like both sides of the paper, but some people don't want to print that way because it's some official contract or something that they're not allowed to be printed on two sides, then we would have two different print queues for that printer. And maybe this print queue is for some other printer. So LPD will take the print job from you, will put it in the print queue, and then the print queue will be sort of attached to this printer, and the printer will pull jobs out as soon as it's finished with the next one. As soon as it's finished with one, it'll pull out the next one out of the queue and service it, and then the page comes out of the printer and it gets all printed on. Okay? And that's what happens in this whole process. So the two main services are LPR is the command that you're going to type, and LPD is the daemon that's running behind the scenes. Now let's add even more detail to this picture. But before I do that, I want to clarify something. I drew the computer over here, and then I drew the line printer daemon and the print queues over here. This is really all on the same computer right now. Think of it that way. The line printer daemon is running on this box. You typed LPR on the same computer. The print queues are on this computer. And then they're hooked up to the printer by some wire. Okay? So this is all one computer right now. Think of it that way. And LPD, this daemon here, this line printer daemon, can accept print jobs from some other computer on the network. And the way that works is some other computer on the network, initiates an LPR command. But if there's no LPD process running on this computer, then that LPR command has to go over to some other computer where LPD is running and pass the print job off to it. And LPD takes that print job and sticks it into a print queue, just like the local process, just like the local print command. And as a matter of fact, LPD doesn't even know whether the LPR command came from some remote machine or some local machine, because printing is so network oriented in Linux that even the local LPR command does the exact same thing as the remote command, and LPD interacts with those in the exact same way, so it doesn't even know whether it's a local or remote job. Okay, now let's add some more detail over to this part of the picture. First, let's think about what happens when you print. What kinds of things are you going to print? So if you're going to print an email message, like a text file, or you're going to print some GIF file or some JPEG file, like some graphic picture, okay? Well, what happens here is by the time that thing gets to the print queues, then it's already been transformed. And one of the things it might have been transformed into is something we call PostScript. Now, PostScript was like the standard printing language back in the 80s before Microsoft Windows even came into existence. Okay? And back then, printers were what we called PostScript ready or PostScript capable. And what happened was the printer had a little CPU in it, had a little bit of memory in it, and PostScript is really like a programming language. It's just a programming language that specifies how documents look. Okay, so that printer would take that PostScript file and it would use its little CPU and memory in there to print the file out on paper. Okay, nowadays printers, especially cheap printers, do not have that capability. And so instead we offload some of that functionality back to the computer that has the print queues. And what we do is in this path in between the print queue and the printer, we have something in there. One thing we have in there is called a driver. Now, you've probably heard of print drivers before. It's just even in Windows they have these now. It's just something that interacts between your computer and the printer. It's something that translates between the two languages that these things speak. Okay? Now when you're dealing with PostScript, a part of that driver or some program that the driver uses is called GhostScript. So GhostScript works in combination with the driver here. They team up so that it takes this PostScript file, it translates it into something that the printer can understand, and the driver sends that stuff off to the printer so the printer can print it out on paper. Okay? Now you don't need to know all the details of PostScript and GhostScript to get your printing working on Linux, but you do need to understand whether your printer is printing PostScript or not, and if it's not, you need to make sure that GhostScript is in this path somehow, and I'll show you how to get it there. Now before we go back to the Linux screen, let's go over a couple more details of printing in Linux. The print queues that I was talking about are really just subdirectories of the var spool lpd directory. So if you go into var spool lpd, under that you'll see all the different print queues. The configuration file that lpd uses is the etc printcap. Okay? Now there are alternatives to LPD. Some of these alternatives, the Berkeley Standard Distribution has an alternative printing system. There's another alternative printing system called LPRing, LPRNG. The common Unix printing system differs in a lot of the details. All these things really have the same basic structure. There's print queues and so on. They have different ways of filtering, like where I was talking about the driver and the GhostScript aspect of the printing system. These all have different features there and different details on how you exactly set them up. The CUPS printing system uses the etc CUPS configuration file instead of etc printcap and so on. And you can read about these if you have one of these already installed on your system. It's certainly worth reading about and using it if it's already there. If you don't, then probably LPD is the way to go, the one that we were already talking about. Now let's configure a printer for our computer. You have to be the root user to do this stuff, so I'll switch over. I think I typed it wrong. Oh no, I did it right. Okay. And the command that I'm going to use is called print tool. This is a graphical user interface that you can use to set up your printer. If you don't have this available, I'll also go through and show you the config files that are edited from this command, and you can just see how to edit those manually. Okay. So we'll do the print tool command, and like I said, this is a graphical user interface. Once it comes up here, you can see everything's empty in here. There's no queues listed or anything. So we'll just create a new queue from scratch. So I'll click New here, and it's going to walk me through this process. Notice here it says nothing will be done until you hit Finish on the last screen. So no configuration files will be messed up until you hit Finish on the last screen. So you can experiment with this and just cancel before you get there if you're unsure of something. So we'll go on and say Next. And what it says is enter the queue's name. Okay, so I'm going to call the queue HP1 because I have a Hewlett-Packard printer. I'm also going to pick a local printer queue because I'm not on a network. If you were on a network of Linux machines, you would pick Unix printer so that LPD would accept LPR commands from other computers, not just the computer that it's running on. I just have one computer here, so I'm just going to use it as a local printer. Okay, so again, I'm going to hit Next. And now it says select the device to use. LP0 is a good starting point. Your next printer you can make /dev/LP1, the next one after that LP2, and so on. So I'm going to take LP0 as the suggestion and just go on to Next. And now it says select a print driver for your printer. Okay, so this is all nice. It's a nice alphabetized list. You can go under the menu here under HP, and I'm going to work down here, and I've got the DeskJet 560C here. So again, we'll go under that arrow. And again, you can see there's a whole bunch of drivers that I can pick. And Perry's rule of thumb is always pick the first driver, and if it doesn't work, pick the next one and pick the next one and so on. That way I can keep straight which ones I picked so far. So I'll do it in some systematized way. Okay, so I'll say that's the driver that I want to pick, and I'm going to pick next again. And now it says about to create the following queue. It's a local printer device. Dev LP0 is the device. It's a DeskJet 560C, and the driver that I'm using is the CDJ 550 driver. Okay, so I'm going to say finish here, and now things are going to be created. You can see now that my queue is listed. It's a local queue. It's on the LP0 device, and let me hit apply here so that I can apply it, and it says, look, LPD restart was successful. So I'm going to say OK, and I'm going to close this now, and we're done with our print tool configuration. Okay, now what we'll do is we'll go and we'll look at the Etsy printcap file. Okay, now one thing you have to notice here is that do not edit this file manually, because changes will be lost. Okay, if you want to edit this, if you want to make a printer, add a printer manually, do it in the printcap local file, and then what happens is printcap local gets added to the end of this file verbatim. You can see here everything below is included from printcap local, and there's nothing in printcap local right now, so this is empty. But if there was stuff in there, it would just be included in here verbatim, and this stuff is automatically generated when LPD is initialized. Okay, so you shouldn't edit this stuff by hand. Go to the printcap local file to edit by hand. But you can see some of the information here that we entered. Okay, HP1 was the name of the queue that we made. The spool directory was automatically made under the var spool LPD directory, like I was saying before, and it's the HP1 subdirectory of that directory. You can see the device here is dev LP0, and this thing down here, the IF, is the filter. Okay, remember how we were talking about what happens between the print queue and the actual printer? There was a driver in there, maybe GhostScript had to be used, that kind of stuff. Well, this wrapper, this filter here, takes care of that, all that stuff for you. It'll run GhostScript if it needs to, and all that kind of stuff. So if you need to run a filter, there's all sorts of filters in there. The MF wrapper filter is the one that it picked by default, and hopefully that'll work. We'll make sure that works in a second. Okay, so that's the Etsy printcap file, and that's how you do it. If you need to edit this manually, remember, go to the printcap local. Now, another thing that you can do with the print tool command is actually test your configuration to make sure you set it up okay, and make sure all the drivers work for your printer. Okay, so you can see our queues up here again, and we can go under the test menu and print out any number of things you can see in this menu. The most common one might be a PostScript test page in US letter size paper. Okay, and I just did that, and it's printing right now, and it's got all sorts of graphics on it. It's got the Red Hat logo, because I'm doing this in Red Hat, so that's part of the test page, and it's got a bunch of other fancy characters and various grayscales of stuff. Things like that are all on the PostScript test page. You could print out a text test page to make sure that works. Occasionally, rarely, but occasionally, it will happen that text will make your computer or make your printer misbehave, and it'll print out graphics and GIF images and everything just fine, but an actual just plain text test page might mess it up. So you want to make sure you test that if you're ever going to print out plain text. You can print out a JPEG or GIF image or a bitmap image or anything like that. And whatever you're going to be printing on your printer, make sure you test all those things out and make sure the driver and everything is, and the filter is capable of handling all that. Okay, so the print tool not only configures your printer, but you can test your configuration to make sure everything's compatible between the drivers and the printer. Now let's look at the more common day-to-day activities of printing, like using the LPR command, and we'll also learn the LPQ command to examine the print queue. And then there's another command, the LPRM command, which stands for LP remove, or line printer remove, and what that does is it removes a print job from the queue before it gets printed. Okay, so let's go down into the scripts directory and we'll print one of those shell scripts that we wrote before. Let's just do the most simple thing that we can. We'll just do an LPR on demo2.sh. Okay, now because I only have one print queue on my computer, the one that we just set up, because I only have one print queue, if I just say LPR demo2.sh, the line printer daemon will figure out that this demo2.sh file should go to that HP1 print queue that we specified just a couple seconds ago. Okay, now if I had multiple print queues and multiple printers on my system, then I would have to go back and specify those. And I can do it here anyway. It's just an over specification since I only have one. But what you do is use the capital P option, and you follow that by the name of the print queue that you want to send this to. Okay, so the capital P followed by HP1 says send the demo2.sh file to the HP1 print queue. Okay, now right when I hit enter here, I'm going to immediately type LPQ so that we can see the print queue. Okay, we can see a textual representation of the print queue. Now remember that when something, when I type LPR, it goes from my computer, it goes over to the print queue inside in the memory, and then what it does is it goes out to the printer. It's only going to be in the print queue for a brief moment, like maybe 2 seconds, because there's nothing in front of it in the print queue printing already. Okay, so this will only last in the print queue for a very short time. So that's why I'm going to type LPQ right away after I hit enter. So here I go. I'm going to hit enter and type LPQ, and you can see here that this is the textual representation of the print queue. You can see the name of the printer is HP1, and it's at localhost because I set it up to be a local printer. Okay, there's some other information here about the server and so on. Here's the information about the wrapper, the filter, you know, the smart filter, or the thing that's going to run GhostScript for us. And then here is the actual items in the print queue. Okay, notice there's only one item in here. It's rank 1, means it's the first thing on the list that's going to be printed. Okay, here's the owner of that job, and here's the number of that job. This is pretty important because if you're going to remove the job from the print queue, you need to know this number so that when you remove the job, you remove it by specifying that number. Okay, so there's our LPR command, there's the LPQ command, and then the LPRM command would be specified with the 299. Okay, but this job's actually already out of the print queue. It's already printed. I can hear the paper ejecting behind me. So I can't do LPRM 299 now, but if it was still in the print queue, then I could do this. The only people that can remove a job from the print queue are the owner of the job and the super user. Okay, so you can't remove somebody else's job unless you're the super user. All right, so that's how I would do LPRM on this job if it was still in the print queue, but since it's not there, I can't do it. But that's the 3 most common commands that you'll use with printing: the LPR command, the LPQ command, and the LPRM command. Now let's turn our discussion to sharing files between different computers. And there's a bunch of advantages to doing this, and I've listed a few of the most common ones here. Probably the most advantageous reason is just for easy file exchange between the computers. You can certainly do something fancy like sending email back and forth from an account on each computer or something like that, but that's kind of a mess, and it's a lot easier if you can just set it up so that the files are shared, and I can go into some directory and copy a file, and that directory might really reside on some other physical computer. And then you can also conserve disk space and also reduce work for system administrators by setting up file sharing. And I'll give one example to illustrate both of these points. So suppose that you want to install some software and everybody wants to use this software. Well, the system administrator can install that on one disk somewhere in one directory and make that directory shareable to everybody else. That conserves disk space because the software is only installed in one place, and it also reduces the work for the system administrator because they only had to install it in one place, and also they only have to update it and maintain it in one place. So these are some advantages of file sharing. For Linux, there's probably 2 typical scenarios that you're going to run into. You're either going to want to share files between your Linux box and some Windows machine, or between your Linux box and other Linux or Unix machines. Okay, let's talk about Windows first. To share files between your Linux machine and a Windows machine, you use a program called Samba. Okay, Samba is just playing off the SMB acronym that used to be the acronym describing the Windows file system. SMB stands for Server Message Block. So Windows used to call their file system the Server Message Block file system. They've since changed the name to the Common Internet File System. The program was written back when SMB was common, so they've kept Samba as the name, playing off the SMB letters. Okay, so Samba is the program that you would use to share files between Windows and Linux. If you want to share files between your Linux box and other Linux Unix boxes, the most common tool is probably the network file system. Okay, this was written by Sun Microsystems, 20 years ago or something, and this is definitely the most common way to share files between Linux and other Linux or Unix boxes. Okay, so now let's go back to the Linux screen and look at how to do some of this stuff. No, you're not going crazy. This isn't the Linux box. This is actually a Windows machine. I just wanted to take a quick little 20-second diversion here and show you what you needed to do on the Windows side of thing in case you didn't know about it. I'm no Windows expert, but at least I can do this kind of stuff. So what I want to do is go into the C drive here and make this folder Perry Stuff. I want to make this shareable over the network. Okay, so what I'm going to do is I'm going to right click on this folder and I'm going to go under sharing and security and left click on that, and now I'm up at this menu. I'm going to click on the share this folder over the network. It gives it a default name, the same name as the folder, and I'm going to keep that, that's fine. And it also has the box checked for allow network users to change my files. I'm going to leave that checked as well. This is truly shared now, okay? This folder here, Perry Stuff, people can write to it as long as they have an account on this Windows machine. Okay, so I'm going to click apply here, and then I'm going to close this window, and when we go out now, you'll see the little hand here under the Perry Stuff folder, and that just shows you that that folder is shared. So now let's go back to the Linux machine. I'm getting so confused here. Let's go back to the Linux machine and we'll see how to access the stuff in this Perry Stuff folder. Now there's a couple different ways to gain access to that share over on the Windows machine. The first way that I'm going to show you is with the Samba client command, SMB client. Okay? And what you do here is you follow this by a double slash followed by the machine name that you're going to get the share from. Then you follow that by a slash, and then you put the share name. And remember, I gave the share the same name as the directory, Perry Stuff. Okay? So this is saying connect to the machine Nugget 2, get the share Perry Stuff, and sort of, give me access to it via the Samba client command. Now the Samba client is assuming that my username on Nugget 2 is the same as my username here, Perry. But it's actually not. My username over on that Windows machine is trainer. So what I'm going to do is give it the capital U option and follow that by trainer. That's saying I want to connect to Nugget 2 as the user trainer. And it's going to prompt me for a password to make sure that I'm verified that I actually am the user trainer. I'm allowed to enter that account. Okay, so I'll hit enter here. And it says got a positive name query response, and now it's asking me for the password. So I'll type in my password, hit enter. And now I'm at the Samba client prompt. This is like FTP, okay? It's like FTP in that it's like this text-based, sort of primitive interface to get files and put files back and forth. And if we do a help here, you'll see it's very similar to FTP. There's an ls and there's a dir. There's the get command and the put command, okay, to get files from the Windows machine and bring them to my local machine, or to put files from my Linux machine out to that Windows machine. Okay, so this is the set of commands that you have available to you. I can do an ls, and now you can see this is the stuff that's in the share. The file linuxsyllabus.txt is there, and there's this directory called Perry, and you can tell it's a directory because all the directories have D's by them over here. Okay, so if I'm going to get that file, I can get linuxsyllabus.txt, okay, and that is going to get the file, and it's going to bring it over to my local machine. So if I quit out of here and do an ls, you'll see now that I've got this file called linuxsyllabus.txt in my home directory, and it's on my local machine now. I can edit this file on my local machine. I can do whatever I want. If I want to put it back over to the share, then I get back into Samba client, and I would use the put command, and I would put it from my local machine out to that Windows share. Okay, so now we can see how to use Samba client to do things. Let me show you another way that you can access that Windows share. Now let me show you another way that you can access those Windows shares from the Linux machine. Okay, and the new command is called Samba mount, SMB mount. And you specify the share the exact same way that you did for the Samba client command. You specify the name of the machine followed by the name of the folder that you want to share, that you want to grab the share from. And then remember the Linux mount command that we learned a while back. You said mount the device that you were mounting and the directory that you were mounting it into. And the Samba mount has a similar syntax. You say the share that you want to mount and then the directory that you want to mount it into. And I'll just mount it into my hold directory that's below my home directory here. And the hold directory is empty, so this will be perfectly fine. Okay, so I'll hit enter here. It'll prompt me for my Perry password. Okay, so I'll do that. And then if I go into the hold directory and do a listing, you'll see the stuff that was in the Nugget 2 Perry Stuff folder. Now there's an important distinction here though, is that this stuff, I mean, it looks like it's local. If I do a long listing on it, I mean, you'll see all the permissions over here. You'll see the Perry folder. It looks like a directory. It's got the D set in front. This stuff, it's owned by me, it says here, and so on. But the trick here is this stuff really isn't on my local machine. Okay, it's still back here on Nugget 2. And if I brought this file, linuxsyllabus.txt, into like a text editor, like Emacs or something, and I changed it and I saved it, it would actually be saved back here on Nugget 2. Okay, so I mean, this is okay. This is probably why you're sharing the files in the first place, is because you want people on the remote machine to be able to save it. Remember, we checked that box back on the Windows machine so that remote users could edit these files and save them and write to that directory. Okay, so this is probably what we want, but just be aware that when you're saving stuff here, you're really saving it back on Nugget 2. Okay, and another command that you should probably know here is the Samba unmount command. So we'll get out of the hold directory so we can unmount this thing. And remember, the Linux unmount command was just umount, so this is Samba umount. And we'll just say the name of the directory that we're unmounting here. And we'll do a listing, and if we go into the hold directory and do a listing, you'll see it's empty now. So the link between the hold directory and Perry's stuff on Nugget 2 is gone now. Okay, there's nothing left in the hold directory. Okay, and nothing was really there anyway, right? It was always linked back to Nugget 2 Perry stuff, and that link was broken when we did the Samba unmount command. One important thing to remember is a while back also we talked about the set UID permissions. Remember that normal people could run commands that seem like they should be root commands, like you'd have to be root to run them, like changing a password file and stuff like that. But normal users have to be able to do some of this stuff like mount shares from Windows machines. And so if we go up into user bin and we do a long listing on the Samba stuff here, I'll do an ls-l smb star. You'll see all the Samba commands here, like Samba client, Samba mount, Samba unmount, and there's some other ones that we didn't learn. But you'll see on the ones that we used that the set UID bits are set. Remember that if an S is in that X position, in the execute position, that means it's set UID, and that means anybody can run it, and they'll be root temporarily while they're running it. Okay, so you can see the Samba clients got it, the Samba mounts got it, and the Samba unmounts got it. And that's why I was able to run those commands as Perry instead of being root. Okay, so if you're having trouble running these commands as a normal user, make sure that get the root user, if that's you or somebody else, to change these commands so that their set UID permissions are set. So our final topic is NFS, the networked file system. And this is definitely the most common way to share files between Linux computers and Linux and Unix computers and so on. Okay? Now to set some of this stuff up, you have to be the root user, so I'll switch over here. Now, the only catch here is that I don't have another Linux box here in my office to set this up officially so that we can actually share files between two computers. So instead, I'll just walk you through the steps, and it's pretty much just the same as the Samba stuff, and it shouldn't be too surprising how we do it. Just a couple little different commands and a little bit different syntax. So let me show you how you would do this. So say we've got some machine named Adams. Okay, and we want to mount on our local machine something from that Adams machine. So I would specify the machine name. Instead of using / followed by the machine name, I'm going to use the Linux convention of machine name followed by a colon. And then you follow that by the name of the directory that you want to share. Okay, so like home John Doe, for instance. Okay, so now then what I do is I give the mount point where I want that directory to be visible on my local machine. Okay, so just like the Samba mount command, we give the mount command. Instead of Samba mount, we say mount. And then we specify the name of the machine and the share that we want to bring to our local machine. Syntax is a little different. And then we specify the local mount point, which is exactly the same syntax as we used before. Okay, now if there actually was a machine Adams here hooked up to my network, after I did this, I could go into the mount Doe directory and I would see all the stuff that was in home John Doe. Now the nice thing about NFS is that all the permissions are carried over from this directory to the mount Doe directory. Okay, so that's what's nice about NFS, is all the file permissions are carried over across NFS mounts. And to unmount such a share, you would just use the umount command, and you would say umount mount/doe. Now, like I said, typically only the root user can mount these things, but the root user can actually set it up so that in the etc fs tab file, this just stands for the file system table file, okay, there's a bunch of information in there. Now, if there was an NFS share that you wanted to mount, the type here would be NFS, okay, for the share. The mount point would be here, the label would be over here, and then there'd be some things in here. If there was a user label in here, okay, with the NFS share, that would say that a user can mount it. Okay, the no auto here says don't mount it automatically. So in this case, you can see the CD-ROM is not mounted automatically, the floppy is not mounted automatically, and so on. Okay, now if there was an NFS share here and we wanted it to be automatically mounted, we could leave out the no auto, and then it would be automatically mounted every time, and the users could just access that other machine every time. And that's probably the most typical way to do it. When I was at a university, when I was at in industry, typically what we would do is when you booted up your system, you would get these mount points mounted automatically, and so I could just access these shares on other computers without typing any commands. Okay, all I would do is cd into that directory and it would be there for me. And there's one final step to make NFS shares accessible over the network. Just like when we went onto our Windows box and we made the PeriStuff folder shareable over the network, we have to go onto the machine, the host machine, and tell that host machine that this directory is going to be shareable to these other machines. Okay, so we were using Atoms as the hypothetical host machine that was hosting the directories that we wanted to share. So what I would do on Atoms is I would go into the etc directory, okay, and I would look at this file called exports, and I would edit that file. Right now you can see that the exports folder, or the exports file on Nugget 1 is empty, but just pretend for right now that I'm on Atoms and I want to set it up so that I make the home directory shareable to all these other computers. Okay, and while I'm doing this, let me just show you one little trick here for editing a file. Okay, a quick way to edit a file. If I say cat followed by a greater than sign and then give the file name, what this does is it wipes out the file, and since the file's empty, that's okay. It wipes out the file. I hit enter here, and you can see I don't get a prompt, because what's happening right now is everything that I type is going to go into the exports file, and then I'll hit Control D to end my little editing session here. Okay? So you don't want to use this if you're trying to just like edit a file. If you're just writing a file from scratch, this is a perfect way to do it. Okay, so let me show you what I would write on Atoms in the etc exports file if I wanted to share the home directory. The first column I would just put /home. Okay, and that says I'm sharing the home directory, and then I would list all the computers that can mount the home directory on their machine locally. Okay, so I'll let Nugget 1 mount it, and then what I'll do is I'll give the permissions for Nugget 1. This says Nugget 1 can read and write to the home share. Okay, maybe I've got another machine that I want to share it to too, called Baker, and I'm going to give Baker read and write access as well. Okay, maybe I've got another machine called Carlisle. Okay, and Carlisle I'm only going to give read access. So RO stands for read only. Okay, RW stands for read write. Okay, so Carlisle, Baker, and Nugget 1 can all mount the home directory, and they have different permissions. Okay, and this is what would go in the etc exports directory, or the etc exports file on the Atoms machine, on whatever machine is hosting the stuff that you want to share. Okay, so like I said, I hit Control D here, and now if you look at exports, you'll see that that stuff that I typed is in the etc exports file. And if, like I said, if this was on the Atoms machine, Nugget, Baker, and Carlisle would all be allowed now to mount the home directory. Well, it's time to wrap up another Nugget with a little review of what we talked about. Our first topic today was printing in Linux, and we looked at the basic printing architecture, and we saw that the line printer daemon was right in the middle of the whole thing. The line printer daemon was responsible for funneling the user requests for printing off to the various print queues. And we also saw how PostScript and GhostScript were involved in the printing process. And then we learned the various commands like LPR to send a job to the printer, LPQ to see the print queue, and LPRM to remove a job from the print queue. And then we talked about file sharing. Our first task was to share files between our Windows machine and Linux machine, and we did that using the Samba program. And then we talked about NFS, the networked file system. And this is for sharing files between Linux machines or Linux and Unix machines. And this is really the most common way to do that. And it's also much more flexible than Samba and much more powerful because it allows us to maintain permissions on the various directories as we share them. Well, I hope you found this nugget informative, and thanks again for viewing.